Hi. So let's take a look at how we can use the Espotec Labrador board. First thing I'm going to do is actually use this little resistor you see in my video screen. So I've got my meter. I'm going to go ahead and measure the resistance. And when I put that on there, you'll notice that it says OL. In my meter, what that means is overload. So if you look here, you'll see I'm a little bit too low. This is actually a 6.8K. Actually a 7 something K resistor. And so I let it settle down there. It says 7.54K. I'm moving it around, so kind of changes. Okay, so now let's hook up this board. Okay, now let's go ahead and hook up our board. So I noticed that I've actually got my Labrador board here connected to my breadboard. So this first little pin is our signal generator channel 1, and I'm going to connect that to my one end or one leg of my resistor. The other side, I'm going to connect to ground, and my particular board has the Espotec actually connected to ground here on this right side. So if I use my little meter plugs here for tips, we can say this little rail running vertically, if you've used a breadboard before, all contains the negative lead, or in my case, the ground lead of my Espotec board here, the Labrador board. Technically, this red line here on mine actually contains the power rail. So that's that adjustable power supply. In this particular case, I'm going to use the signal generator as an adjustable power supply. Okay. You also notice that I've got these two wires connected. Um, both of them are connected to uh, the oscilloscopes. So this is oscilloscope channel 1 on the blue and oscilloscope channel 2 on the red. And conveniently, over here to the right, there's some duplicate uh, pinouts so that we can connect multiple things to that particular channel. Right now, I've just got it connected to the DC segment. Since this is mostly a DC class, we'll be using that DC pin frequently for setup. Okay, so I'm going to use one of the legs. So in this case, let's use channel 1. And I'm going to connect that here so that I get my signal out. So that's this first wire here. So that's the signal being generated, which is in this case going to be that variable power supply. And we're going to pass that into channel 1 so we can see that on our oscilloscope. And I'm going to take my other side, this red wire here, and that's going to be, and we can put it as the output here for our particular system. That's not going to be super interesting. So let's take a complementary resistor here. It's going to be another 6.8 and plug it in. I'm actually going to build a voltage divider. So I'm going to move my ground over, put this in here. Okay, great. So what I'm actually just going to walk you through is using the different functions on our software tool. So now that I've plugged everything in, you should see a little red light come on your board. That red light just means the power supply, the variable power supply is up and ready to rock and roll. So now if we take a look at the screen, you'll notice there's a whole bunch of noise down here. So if you end up with the calibration screen, and to see my calibration video, to go through that process of calibrating all your oscilloscopes and power supply in this particular board. So I've got both my oscilloscopes checked, so that's channel 1 and channel 2, and you're probably thinking to yourself, why am I only hooking up one of those leads from my oscilloscope to my board? Doesn't a multimeter have two leads. So I'm pointing to these two leads over here. Yes, they do. But one of the nice things about the oscilloscope on this particular board is that negative lead is already wired into the ground pin of the board. So essentially what you're measuring against is the ground of that particular cable. So that relative voltage. And the ground is directly connected to the outside of the shielding of our USB cable, which essentially is hooked directly into your computer, which then goes back to the ground of your home. So if you have a funky ground going on in your home, then it could potentially get some noise. But we'll assume that we don't have that for this particular case. All right, so let's take a tour. So I'm going to put in the signal generation. So signal generation, again, correlates directly to this first pin on the board. So that, in this case, is the yellow wire here. And we're going to measure in channel 1. So again, channel 1 is this greenish wire, a little bit hard to see. Green, blue, actually it's blue. And then channel 2 is this red wire. I'll shine a little bit of extra light in there so that you can see what's going on. So channel 1, blue, channel 2, green. And then this wire over here is taking us back to ground, essentially completing our circuit. Again, this is a voltage divider, something we'll see in our circuits a little bit later in the lab. But I've got two equal resistance in here. And what I'm expecting is to get a halved voltage whenever I saw originally. So that's what I'm going to see in this red wire. Let's see if that's the case. So if I kick on, so I've got right now a frequency of 1 kilohertz. That's fine. We'll leave it in place. But I'm going to start ramping up my voltage. And let's take it up to 1 volt. And if you notice down here in the screen, it's kind of moving all over the place. But you'll notice a blue line and a yellow line. So let's hide things so we can kind of see what's happening here. So if you notice that channel 2 is associated with the blue line. So where was the channel 2? Kind of got them backwards here and tricking you. But my red wire is my channel 2, which corresponds to the blue line. So we're expecting that channel 2 from the oscilloscope to be roughly half of the input. So channel 1 in this case represents what we're inputting into the circuit, i.e. it should match exactly what we have in our signal generator down here. So it says 1 volt or 1,000 millivolts. It's our amplitude. Let me pause that. And if we look on here, we say, oh, does that actually correlate to 1 volt? Doesn't quite look like it, but let's clean stuff up down here. So I'm going to turn a few things on. So I'm going to click up here to oscilloscope. I'm going to turn on channel 1 stats, put the mean. Might as well kick the max on there. Sure, let's just add them all. Min. And then channel 2, I'm going to do the same thing. Max, min, mean. A little bit later in the course, we'll talk about RMS, but might as well throw that in there for now. Next thing that I added that you might not have in yours is I added the cursor stats as well. And the last thing I like to do is show the range dialog on main page. So I'm going to add that one as well. So what that's going to do is it's going to give us the option to go ahead and edit our window, which is pretty darn handy in this particular case. You can just cycle through it, or you can type in your values directly into that window. So -2 volts gives us that lovely little signal. Excellent. And I'm going to shrink the time. So time is our x-axis there. So if I shrink the time, what happens? We expand things. We get a nice big view of things. Yeah, about 4 milliseconds would be fine for our particular case. Notice in my screen it's getting a little jumbled up here. So I'm going to go ahead and turn off RMS so I have a little bit more real estate to see what's going on. We're not going to need min in this case either, so I'm going to take that off. So let's unpause it. So I'm going to click that unpause and let it go. Okay. So nice thing is it gives you a readout here of max. So this tells you what the maximum voltage that we're getting, or i.e. the amplitude for this particular case. And this one's given us the amplitude of channel 2. So as we crank this up, this is what happens. We start cranking up our max voltage here. So something to kind of keep in mind is as I crank this, notice what happens. And this is something I really wanted to kind of get you to pay attention to. It will cause a lot of frustrations. Um, I've cranked this up to 5, and it seems like nothing is representative of my particular system. But notice this clipping at the top. So you see how it's kind of cut off. Um, why does that happen? Well, without getting too much of the details, it has to do with how this whole circuit's wired up, how the board's actually manufactured. So what I need to do is I actually need to crank up my power supply. Let's crank it up. Let's crank it up to 12. I feel like we should put it at 11, but that's a joke for another day. And so if I unpause that, you'll notice that it fixes those peaks. Um, Ideally, we'll want to make sure that we lock our power supply so that it's a little bit above where we expect to have our signal generator. But in this case, uh, it's good to go ahead and just crank it all the way up. For all intents and purposes, that's something that you can just always do. So next thing I wanted to kind of address here is you may be getting some kind of funky results. And so I just switched, put sine back in here, all over the place, right? A little bit hard to see. We were at one kilohertz. Let me put that back on the screen. So you notice my value is kind of not what we expected there. It says 2.5, and down here I see I have an amplitude of 5. So I'm getting some funny business happening there. One of the things I need to do, a little hard to see on the screen here on the video, there's actually 2 pins associated with the signal generator. One is listed as a signal pin generator AC, and one's DC. It's actually the second one here that we want to connect into. Let's move that over, and we'll notice something dramatic changes. So that max value, right? So max should correspond to what we're getting down here at our amplitude, and that's exactly what we're getting. So 5 volts. So we've kind of fixed that. That's great. So I can go ahead and crank this up. And what I'm expecting is to get roughly the maximum value here, should correspond to my amplitude. And my max value over here should correspond, since this is a divider, and they're equal, so cutting it in half, we should expect the value to be about half. And it is. So instead of using sines, cosines, and all those fun trig functions, let's just do straight up DC system. So in the DC system, we'll off the screen. So let's bring this down to 3 volts. There we go, 3 volts. And if you want to see both signals, I'm going to crank up this Vmax so we see them both on the screen. Crank this down if I want to see all those lovely wiggly lines. So I'm getting my max voltage, 3 volts. So that's what I'm measuring on channel 1. Again, that's what's coming right out of that power supply, i.e. the signal generator. And channel 2 right in the center there. So we're getting half voltage. Okay, let's play with a couple more things in here. So I'm going to unclick the oscilloscope, and you'll notice we get a little red box down here, which just tells us we have more memory in our buffer to use one of our other measuring tools. Right? So our measuring tools, i.e. the multimeter, the oscilloscope, channel 1, and oscilloscope channel 2, consume some quantity of memory. We have a limited amount of that on our board. I'm going to uncheck this box. I'm going to click the multimeter. Those little pluses on the multimeter really indicate that they're going to consume both of these little boxes down here in the buffer. You'll notice they'll just disappear. And my meter says that I'm measuring about 1.6 volts. So you're probably thinking, well, what does that measure up? So interesting with the multimeter is what it does is it basically takes our difference between channel 1, i.e. this blue wire, and channel 2, the red wire, from our oscilloscope channels. So it's a difference between oscilloscope channels. If you look back up here on the display, 3.1 minus 1.56 is roughly 1.6, 1.61 as it moves around. We could take the mean, that's about 1.54. Yeah, thereabouts. So we end up with a pretty nice measurement of the difference between 2 points. But again, you can't use your multimeter alongside your oscilloscopes. You can only use either the two channels of the oscilloscope or your one channel of your multimeter. Again, is it great to use the multimeter? There's some plus and minuses to use a multimeter built in. There's some interesting features like capturing I, R, and C from this multimeter. But generally, we'll use the oscilloscopes. And finally, let's just take a look at this variable power supply, see if we can measure it and use it directly. So I'm going to go back to my board, and I'm going to remove this pin, or this wire that I've got connected to my signal generator. I'll actually hook it up to my power rail, which is down there. So this little red section on my breadboard is linked up behind the board to this pin here, which happens to be my power supply. And my variable power supply right now is sitting at 12 volts. And since I'm running this across, I'm measuring the voltage across half of my divider, I'm expecting a drop that's half of my power supply, or 12 volts. So I would expect to see 6, and that's exactly what I see, about 6. I'm moving it around, so I'm going to move it here. So we're measuring, I've changed my power supply. So if I lock it and unlock it, I can move this around. Let's move to 5.5. That in place. At the divider, it's about 2.6. I'm going to move that over here to the other side of my whole system. So I'm expecting to drop the same as my power supply. And it's close, not exact. Expect it's not always going to be exact.